Hey everyone, this is the ML Bull here. This is the first of several videos where we're going to look at doing machine learning, artificial intelligence, and applying it to the FX market. The only thing I promise you is that you are not going to make an obscene amount of money doing this, but lots of people ask me all the time because I do it, I make a little bit of money, and it can be done. So we're going to do this as an interactive kind of session over many weeks, and each one will build on the next. I trade live, and there are ways to do it, so I wish you well in your journey. First things first, this is in no way financial advice. This is in no way encouraging you to trade or to do anything or to follow the techniques that I personally use. If you choose to watch this, consider it education in terms of how the FX market works, as well as the ML techniques that we'll go through and applying them to the FX market. It is educational in nature. It is in no way meant to be financial advice or planning. The other thing is a little bit about myself. So I am an engineer, and then I moved into commercial roles after a software development career of a long time. And in doing that, I also learned a lot about commercial transactions, how it works, etc. So I've been trading FX 20 odd years in different capacities, and doing it both manually, automated trading systems, and more recently in the last 5 years in AI/ML based techniques. And we're going to go through in the coming weeks lots and lots of them. But each week we'll build from a hello world example onto different mottos. All right, so let's get into it. So let's get started. Real hello world example today. It's going to be super simple, not really useful for anything. You need to know a little bit of Python, a little bit of basics of FX, and kind of everything else I've got ready for you. But we'll get started. We'll put this together, and then in the coming weeks we'll build on it into something that's a bit more useful. And over time we'll go through a lot of different permutations and combinations. So get yourself onto Colab, which is a nice easy way to get started. It's run by Google, and it is simply an easy way to run ML. If you don't have a Google account, just go ahead and create one. It's all free. It's not going to cost you anything, and you're not going to run very deep, long learning projects, but it's a good way to get started and figure it out. So go ahead and create a new notebook, and when it comes up, we'll start going. So let's get started. The first thing we're going to do is use a lot of pandas in this one. This is the pandas data frame. It's got the basis of a lot of storage. It's a good way to store data, particularly time series data. And we are going to use some date time manipulation as well. So let's put that in there. Now I'm going to cut and paste this link here. In fact, I'm going to cut and paste links too, because I worked this out earlier. So this is a link to my GitHub where you'll find this code, but you'll also find a few other projects and so forth. But this link has got some FX data that we'll use for this project. You can't use this data in the real world. I've manipulated it a little bit just to help us out here, but it reads nice and easy and so forth. I'll show you in just a second. So our data frame is p dot read csv. We're going to use a URL. Now the dates in this data frame and the CSV file are a bit funny, so we need to manipulate our dates a bit using this date parser that you see I've got up here. Equals dates parse. There we go, and that'll put them in the correct order. Yeah, let's have a look at the first 10 or so. So let's see what happens here. And you see it takes a little while to process. That's the price of free, I guess. Let's see how we do. Oh, we have an error. Equals. Sorry about that. Let's try that again. We have another error. We're going to exit pass date. past dates be the correct term. And there we are. And what you can see is the fields from the CSV file. I'm assuming everyone knows what a CSV is. The given is it came from the raw data source. We'll be talking through this in the coming weeks about where to get data and the ones I use and see if that helps you at all. But this has got Aussie US and Euro US, and we're going to focus on trying to predict Aussie. It's a bit more volatile and a bit more easily moved, not by the money I use, but perhaps by some. So it's a nice, easy way to do it. All right, so part one, get our data. We have that. Part one complete. Okay, so for part two, we're going to add a new section of code. And the good thing about Colab is it lets you run code in these sections. So what you've done before remains and stays. So we've got this variable dhead that we can, df that we can manage and still use. So from here, I'm going to cut and paste this code so we can stick it in and I can explain what's going on here. It takes a while to run, so we're going to do that. We won't be needing that. Alright, so what's going on here is first to install this MPL Finance package, which is based on Matplotlib and it's just graphs, financial packages. It works pretty easily, it's pretty self-intuitive. Then we're going to just create a dedicated data frame just to handle the graphing, just so we don't screw up anything else that's going on. And the graphing package looks for open, high, low, close volume terms within the data frame. So we'll set it to the Australian dollar values against the US dollar. It needs the date to be the index. That's important. The other thing, I took it out here, but occasionally the volume won't be in a float. Sometimes it comes out as a integer, and that will cause problems. This MPL Finance package likes the volume in float format, so you might have to change it if you find you're getting that error. And then this final line here is we chart it. So we have the volume turned on, so it charts the volume at the bottom. We'll set the datetime format to just a year, and the reason for that is if you do it with the whole date, it's going to get a bit messy and a bit congested, so just keep it to date. 7 years of data is quite light. And when you are graphing long periods of data, the candlestick format just looks stupid. It's too condensed. It doesn't work. So just use a line type, much more sensible and easy, and it just works. And there we are. There's our chart. You can see there's about 7 years of data in that. There's ups and downs and different volume clicks and so forth. So that leads us into our next question, and part 3 is, what's our hypothesis? What is it that we're going to do that's going to lead to successful trading? All right, part 3 of our Hello World experiment here. Let's create a new section of code. Again, I'm going to cut and paste some work I did earlier and explain it to you. So we just need to reset the types. The MPF plot function doesn't like it unless everything's in a float. It goes a bit crazy. So you need to set that. And then we do the plot itself. And we're going to limit the days to just these days. And the reason I'm doing this is that I know there's a sudden time movement. I know that because I went back and I looked on my trading system to see where was there a big movement. So we'll graph that and we'll see what it looks like. The good thing about using a time series in data frame, of course, is it knows what that means. It just kind of figures that out. So you can see here, there's this sudden movement here, this big sudden movement at this point. And here's our hypothesis, is how do we predict that? Or what is it that we know in the past predicts the future? So what we're going to say is that there's something in the previous data that predicts the future data. Now, we're not going to get into, in this Hello World example, events and whether it's daily or hourly or weekly or whatever it is. We're just going to make a simple assumption, and then we're going to test our hypothesis against that. So the assumption is going to be there's something in the previous periods that predict a sudden movement within the next few periods. So if we were to say, for example, there's something in the previous 4 periods that predicts a sudden movement sometime in the next 4 periods. So this sudden movement here is about 780 points from open to close. To the low, it's even more. It's probably more like 1,000 points. So it's a big shift. So if you look at the previous 4 periods or the 4 periods before that, because we're going to say that any of the 4 periods after. So is there something in that data that indicates that change is coming? That's our hypothesis. That's what we're going to test. And that's the way kind of this time series idea works, is you have things moving in time and there's something in it. There's some unknown object or unknown correlation that predicts what's about to happen. Now that may or may not be true. We'll be talking about stationary data and how that works a bit later. And we're going to see that in our hypothesis as well. So let's move on, prepare some simple data and see if we can test that hypothesis. Okay, so we have to prepare our data based on our hypothesis. And what we're saying is there's something, we're going to make this up, there's something in the previous 4 periods, 1, 2, 3, 4, that predict a movement in the next 4 periods at some time in the next 4 periods. And what is that? Or what can that be? So we're just using the price now, the closing price, to say that we're going to predict that. That's not a real world example, but we're going to do it just to make it simple and easy. And then we're going to shift things around. So let me show you what I mean in terms of data preparation. Let's create a new section of code. And then we are going to just reset our data frame a little bit so we don't get confused. These are the only variables we need. Let's keep it simple. And then we're going to use the shift function to create our data. So shift looks backwards at different time periods. So we're going to create this X, 1 time period ago, shift 1 back, 2 time periods ago, shift 2 back, 3 time periods ago, and 4 time periods ago. And that creates the close price at the last 4 periods in the past. The idea here is that's our 4 back periods. That's the information that somehow leads to a change in the future. So if there has been a big change, the future price will be 4 periods. But remember, we're starting at 0. So 0 open price, the close of 0 is the first movement. So it's actually -3, which is forward 4 periods, 0, 1, 2, 3, 4. And then the price change, or how much it's come, will be the future price that we just calculated minus the open price, which is true for this period. Let's convert that to points, like that. And that tells us how many points have elapsed. And then the last thing is we're just going to use an NP-where to create, if it's more than our threshold, which we set was 200, which again, random in our hypothesis, more than 200. We'll be going in a later podcast into how that works and why 200 and why 400 and what we might do, and we'll look at the different options here. But that gives us our why. Interesting, we've got a little squiggly line or an error on NP here, so I haven't yet imported NumPy. If you're not up with NumPy-where, getting to it is a really handy function. And lastly, and not leastly, let's have a look at the results. So let's see what, oops, a little error there. Let's see what that looks like. And here we are. So here's the open and close that we copied at the top. You see a lot of not numbers here. That's because we're going back 4 periods. And for the first one, there's nothing to see. There's no back periods. So the first one's going to be all not numbers. So it really doesn't start until the 5th period or period 4. The way we go, you can see the price change in points, and a value of y. So these 4 numbers we're saying predict y. And you can see we have to go a long way down until we see a 1. And that's the first one we see. So what we've got is we've got an awful lot of zeros and only 1. 1, and that's in the first 30 or so. There's a couple more here, but fundamentally we don't have a lot of 1s. What that means is we have an unbalanced data set. Now, we're not going to worry about that today. We'll see what happens anyway, but we are going to come back and correct for that in next week's podcast. All right, so that's our data. We're ready to go ahead and train our system. Okay, so we've got our data ready, we're set to go, we're ready to start doing our training, etc. So let's go ahead, create a new section of code, and I'm just going to cut and paste here. We're going to use logistic regression because it's the type of model we're just going to start with. It's a simple model, it's easy. The first thing we're going to do is separate our data into our training set and our validation set. And the reason why that's important is we don't want to learn on data. We don't want to learn on data we're going to test on. And that's because if we've seen that data in our training, then we probably know what's going to happen. And as a result, we skew our results because we can't look forward into our real world. So it's important to keep those two things separate. So our X data is our fallback periods, and our Y data is just that Y variable. Logistic regression, I'm not sure if we spoke about it earlier, but it refers to this idea of a binary output. So a bunch of inputs and a binary output, 1 or 0. It's very simple, it's nice and easy. It's going to be easy for us to explain and work through that. So I've normally said we're going to use 70% of our samples. Remember, we've got about 7 years of data in our training samples, and the rest in our validation or our testing data. And then we just go ahead and create that. You notice we don't use the first 4 because if you remember, we have a lot of numbers because of the offload. Let's go ahead and run that. Brilliant. We are now in position to do our logistic regression training and fit the model. This is the guts of it. This is where the smart bits happen. And that's quite disappointing, isn't it? It all ends very quickly, but our model's now been fitted. Okay, so our model's been fitted. We need to somehow look at what it's done. You know, has there anything interesting happened? How accurate is it? These types of things. And what you're going to hear people talk about is variables in logistic regression like confusion matrix, true positive, false negatives, all these types of terms. They're generally useful in FX training, but not to the extent you might think. That's certainly not what we're going to use. This is what we're going to focus on today, but next week we're going to build on that. Over the coming weeks we'll be building on it even more. So firstly, let's keep it simple. Let's just predict from our validation set what we actually have. And let's see what we get here. Okay, so the LR, if you remember, that's the model, logistic regression model from sklearn. And again, presence is a lot of zeros there. Okay. And that's pretty much what we're going to find out. So I've imported these functions from sklearn, log loss, confusion matrix, precision score, etc. And what they're going to do is allow us to calculate some of these basic error types. And our goal here is to move towards a basis of comparison. So as we change and modify and do things, is it better or worse? And that's what we're looking to use with these variables. So look in the show notes. There's an article I wrote on Medium that explains how these different terms work, what they are, etc. And you should go through that. So let's just go through them very 10,000 feet. The log loss is a measure of the machine learning error between individual data points. The score is what sklearn puts together intrinsically to measure accuracy, and accuracy gives us how often we predict correctly. That's fundamentally what it is. The confusion matrix has got 4 components in logistic regression, being the true, false negative, false positive, the false negative, true positive, and they help describe, particularly true positive is probably the most important variable. And what that is if we predict it, did we get it right? What's the count of the number of those? The other side of that is the false negative. So if we predicted it, did we get it wrong? Because if we predict it, we traded it. We took a risk. We spent our money. So those two things are the most important things we have. And the precision is a measure of the relationship between the two. So if we predict it, how many do we get right? And we get that percentage. So as we go on, we'll be using more and more about true positive and the precision. Recall is a measure of what we missed out on. So how many times did it actually move quickly, but we didn't predict it, we didn't make the trade. And the F1 score is a measure of the relationship between precision and recall and getting that balance right. So I've just put down some code here to print out all these errors. Again, I've taken all these metrics straight from sklearn, so it makes it really easy for us to do. So the loss is 4.4. It doesn't mean anything to us. As we go on, we'll use it as a basis of comparison to see if we're lowering that error by doing certain things. But by itself, it really doesn't mean anything. You can see the score that sklearn has given us 87%. Sounds pretty good. If you look down, true positives, 0. False positives, 0. That means we didn't predict any opportunities to trade. So this score idea, 87%, wow, that sounds good, is pretty meaningless in this example because we didn't predict anything. We didn't make any money. The good news is we didn't lose any money, which is often a problem in this type of trading. But so this model, as it stands, is pretty ineffective. Really not going to do anything. So next week we're going to build on this a little bit and see what comes out. So there you have it. That's our Hello World example. As you can see, it really didn't do much. So next week we'll be building on it and making it more effective and getting it somewhere towards usable. We're also going to talk more about how we measure it, because these numbers, true positives, etc., in this form, not quite right. So we'll be looking at how we can make that more effective as well. That's it. If you look at the notes, you'll find the write-up that goes into a bit more detail, Twitter handle, and the full article on Medium. That's it. Leave any comments. Love to have your feedback, and we'll see if we can make it more effective. Cheers.